Hello everyone, welcome to YouTube channel Project Professional. I am Tanveer and you are watching the video on EPC project schedule shift to systemized construction. To start with, let me explain what is systemized concept. So in order to know that, you have to know that what is area concept. Okay, so when the work is done based on a particular type or discipline or area of work, like pipe rack installation, foundations installation, cable laying, piping, equipment installation, etc. They are known as construction under the area concept or bulk construction. While when the work is focused on subsystems and systems, which may comprise multidiscipline and multiple area, they are called systemized concept. Then let me explain what are systems and subsystems. To understand the concept, the foremost is the understanding of the systems and subsystems. Systems are part of the process plant or process facility, which may be separately and individually completed. Systems may be categorized under process, utility, infrastructure, etc. Then what are subsystems? Subsystems are part of systems which are operable entities. Okay. Then little bit into the detail. Systemization is the process of breaking down the processing facility or process plant into systems and subsystems. This exercise, when it is done upon the finalization of P&ID, which itself is during the detailed engineering. Each subsystem comprises of inspection test records, ITR, or quality verifying documents, QVD. It is either called ITR or QVD. It depends on which completion sheet one is using. ITRs or QVDs, as they may be called, are further categorized as A, B, and C. And then let us know what are these categorization, what is the basis. Category A are to be closed prior to mechanical completion, walk down. Means in order to start mechanical completion walk down, you have to close all the AITR or QVD as it is called. Then what about B? B, you have to close during the pre-commissioning, and C, during the commissioning. Then let's see the working of systemization concept. Completion of AITR or QVD as it is called. Then upon that, mechanical completion walk down can be initiated. After the mechanical completion walk down, generation of punch A, B, and C. Punch are generated, then they are categorized as A, B, and C. Then upon closure of punch A, issuance of mechanical completion certificate. It may be noted that this process, it may be carried out at the subsystem level, at the system level, or at the facility level. It depends. So the strategy, what one is adopting. So as we see, until the closure of a punch, these are pre-mechanical completion phase or stage or whatever one can call it. Then next is after that mechanical completion certificate, what we do is the completion of BITR or QVD and also closure of B punch. Then once both these activities are done, the pre-commissioning is complete. So these are all pre-commissioning phase. After that, what we do? Review or audit of safety prior to startup. Means it is just to check that, okay, it is safe to commission and startup and commission. Oh, sorry, commission and startup. Once it is done, when it's okay, and here also, whatever is the points or punch generated, we have to close. Then we can start. So there are also punch which has to be closed prior to start of commissioning, and there are some categories which can be during the commissioning. So after that, what we do, we start the commissioning and then complete the commissioning. After commissioning and stability, what we do the performance test and all those things, and then we say if it's okay, then we can close. Then one question is that when and why to shift to systemized approach. So the answer is generally when the construction reaches near the first answer is when. So generally when the construction reaches near completion, the shift should be from area or bulk to the systemized approach. Construction starts with an area or bulk approach because the systems and subsystem may comprise of piping over pipe rack, rotating equipment, instrument, electrical component, etc. Like when we start the construction, we do the civil work, and then the pipe racks are constructed. On the pipe rack, there are so many pipes are there. So we start laying because those pipes may belong to different systems and subsystems. So we cannot adopt those process. Similarly, the cable is going, so they might be part of different systems and stuff like that. So that's why it's an area or bulk approaches at the start. Like so, but as we go on, the scenario changes. So then why shift to at late construction? Means why shift to the systemized approach at the late construction? So I will explain why. When the construction is at late stage, all the components of system and subsystems are complete. A system or subsystem may comprise a pump, piping, instrument, and all those things. So at we approach late construction, all this gets completed. So we and second, this is one thing. Second is the mechanical completion and pre-commissioning can be done independently on system and subsystem. Pre-commissioning, if you have to do, you have to do in the based on the subsystem. In order to, so one example of why pre-commissioning can be done on subsystem system approach is that all components of systems or subsystem comprising pump, like the system comprising pump, has to be ready to carry out the functional tests, which in turn require completion of corresponding AITRs or AQVTs. So that means we have to shift to this systemized approach before the mechanical completion, means before the walkdowns. That's right, because what we see that the BITR or BQVTs, before that it has to be AITR or AQVTs. So those are all associated with the subsystem and system. So we have to shift to that system. Okay, that will complete the particular subsystem, then mechanically complete, then we'll go to pre-commissioning. System sequence in pre-commissioning. Not only this, there also in an ideal condition, the pre-commissioning is done in a proper sequence to support the schedule and seamlessly start the commissioning. So it has to be in a proper sequence. Sequencing of pre-commissioning requires alignment of systems and subsystem mechanical completions accordingly. If you have to align this pre-commissioning in a proper sequence, then you have to do it prior to that. During the mechanical completion, also those system has to be accordingly completed. This is idealistically represented by a fishbone, which we'll see at the later slide. This example of fishbone, if we see that, okay, it is from left to right, and all the nodes are there like safety system, this should be first priority. Then next should be the electrical, then instrument. These are all system, maybe process here, and later shipping and transport. Okay, because we have to send the product somewhere or product somewhere. So and we see these systems system form the tertiary on the fishbone, which represent the subsystem. And also we see at the the dates are completion dates are also can be put. So this represent how we proceed with the date wise. Then we have talked so much about AITRs or AQVDs. What are these things? So after completion of an activity, request for inspection RFI is issued and inspection is carried out. The component where the inspection are done are part of the subsystems and intern system. Like we do the hydro test of a piping. So we make a part wise of a system. So it is a part of the system. And similarly, the other inspection. These RFIs feeds to the AITS or QVDs, as I gave the example of hydro test packs. Okay, hydro test, reinstatement, and all those things. When these RFIs are closed, the corresponding AITRs or QVDs are also closed. An AITR or QVD may comprise of one or more RFIs. So a particular AITR or QVD may have one or more RFI. Similarly, a subsystem may comprise multiple AITRs or QVDs. Mechanical completion and pre-commissioning. In a systemized approach, the subsystem walkdown is done when all corresponding AITRs or QVDs are closed. Similarly, the mechanical completion is achieved when all A punch items from the subsystem walkdown is closed. So when all AITRs are completed, you start a walkdown. When you start a walkdown, you generate punches, which are categorized A, B, and C. When all A punches are closed, then you achieve the mechanical completion. Pre-commissioning starts after mechanical completion, and during this time, all BITRs or QEDs corresponding to that subsystem along with B punches are to be closed during this phase. A items correspond to construction RFI. Examples are A items corresponds to construction RFIs. So examples are hydro test package, temporary reinstatement, etc. B item correspond to functional RFIs. Example, leak test or flange integrity test, stroke test, mechanical run test of pumps, compressors, like that. Punch items are the deficiency observed with respect to approved drawing and document during walkdown and at some other intervention points. They are categorized as A, B, and C. These should not be confused with A, B, and C ITRs or QEDs. A punch are to be closed prior to mechanical completion, while B punch before starting commissioning and C can be closed before the turnover. So this is the sequence. That's all with this video, and hope you like this video. If you like this video, subscribe to YouTube channel, share this video and the other videos on the YouTube channel. That's all what I can say. Thank you. Bye.